by taking Yeah. All right. Okay.
All right. Good afternoon, everyone. My name is Chang, and similar to Tom, I work with EDF Energy. Now, my presentation isn't technical as well, and in fact, I don't think there's a lot of my presentation that you can take back as fact. It's mostly my opinion. But what I hope to bring to this presentation is that you would be able to go back and have some things to think about. All right? So I'll be talking about the energy paradox. Now, why the energy paradox? I don't know if it's the same for all the other contestants, but initially I wanted a flashy name for my title. So this was the best word I could come up with. But now that I've got to this stage of the competition, I actually have to talk about it. I really put in a lot of thought into this, so you guys better be impressed. Right? That's another thing off my list to present the audience. Alright? So, the energy paradox, if you have a look on the internet, you'll find a few references to the energy paradox, but I'm not talking about those. What I will be talking about today is to do with energy generation. And the paradox goes something like this. Alright? The search for the perfect energy generation method will only fuel the development of existing methods. It will not replace what we have now, but it will only make them better. Right? So, right. As an example, we'll go through some of the existing methods we have, and then I'll go straight into the paradox that we have that I just mentioned just now. Now, I won't go into too much details into these existing methods because I'm very sure that most of you will know more about this than I do. So I'll take you guys briefly through this. Right? Fossil power. We know that it's been preferred for so long because it's responsive to the energy market, especially gas turbines, where you can just switch them on and switch them off. Right? And infrastructure has been built in place throughout the years to support it. But the biggest disadvantage of fossil power is the high CO2 emissions. So I casually took these values from the internet, but they look reasonably accurate to me. As you can see, the CO2 emission per kilowatt hour of generation for fossil power is generally quite high. Now, if we look at wind power sounds like the perfect option on the surface because it's renewable, it's low carbon, and as far as I know, wind is free, isn't it? So, what's so bad about it? But we also know that wind power can be unpredictable. You don't get consistent energy generation, and there's a very narrow range of operation, and this limits its application in a lot of instances. If we move on to solar power, again, solar power sounds like a very good choice because sunlight is also free, it's renewable, low maintenance, low carbon again, but it requires a high capital cost. And it's inefficient. Right? As mentioned just now, it's not without the radioactive waste. And the management of this radioactive waste is very important because recent events in Japan and the strong reactions we're getting in Germany, this has all to do with the management with the radioactive waste itself. Plus, it also requires a high initial investment. So, how will the search for this perfect generation method affect all of these existing methods? I think there are three ways to look at it. Firstly, the generation method can only be perfect if there's a set of criteria defined for it to be perfect. Right? It might be that it has to be low carbon, reliable, this is really dark here, I don't know why, but anyway, responsive, low cost, and so on. Now with this set of criteria defined, it helps push our existing methods towards perfection. Do you get what I mean? Like modifications can be made based on these criteria to make existing methods better. Take fossil power for example. Now that we know what we want is for high efficiency and low carbon, we have combined cycle gas turbines. And unsurprisingly, they are more efficient and produce less carbon dioxide. Right? Do you understand? No? Yes? I'm moving on anyway. Second point. fuel this research for the perfect generation method, the power has to come from somewhere, right? The more experiments we conduct, the more power we need. Plus, we still need a living, all right? So where is that extra power going to come from? I believe that this will naturally push up the standards of existing methods to meet that extra demand. And finally, the failure to develop a new and innovative idea in the short term will only remind us of our dependence on our existing methods. Take nuclear fusion, for example. It's always 50 years away. Is it ever going to come? We have needs and we have targets to meet here and now. Can we really hang our hopes on nuclear fusion as we sit around and wait? I believe that technologies for existing methods will constantly improve year on year as we strive to reach this perfect method. We'll always find better ways of doing things as long as that perfect method is not found. So, because of all that, I strongly believe, and I would like to reiterate, that the search for the perfect generation method will not replace our existing methods, but they will only make them better. Now what you will see here is the contribution of different generation methods in the UK, right? So in the future, you might see some changes to these percentage values because of improvements, in technologies in certain areas of different generation methods. But what you won't see generation method will not replace what we have now, but it will only make them better. And that concludes my presentation. Thank you. Happy to take questions, but hopefully not too difficult ones. Thank you.
Would like to start off? Glenn?
Thanks, that was an interesting presentation. You don't believe there's a perfect method of generation. What do you think comes closest to that, and why?
I think what we currently have, which is a mix of the different generation methods, is as close as we'll ever get to, the perfect mix. Because I don't think there will be one method that will meet all our needs. If we want renewable, we will need to pay the price of unreliability or low efficiency. And if we are moving towards nuclear, then we would have to live with the radioactive waste. It's about how we manage it. So I think the perfect answer would be a mixture of all of them, not one that's going to, give us everything we need.
Next question.
You don't see the extension of any of the power producing stations like oil power plants. You don't see them disappearing from each other.
Not in the near future. I don't think that's going to happen. Because apart from coal, I think it's an exception.